Thank you, Lawrence. Good morning to everyone. So we will start delving into some more practical information and things about the work we have done in the previous projects and is still and is in progress in the EU-FarmBook project. I will provide some background information about the currently available version of our platform, some useful facts, what is currently in there. Of course, we need to dig a bit deeper into the work we have done. We need to see what is below the surface of the sea, take a look at the part of the iceberg that is below the sea level, and see what is the challenge that has let us dive into all this design and development related work that we are currently undertaking. Of course, we will say a few things about how we envision the collaboration between our platform and the work that is being done in other projects at an abstract, at a top-level layer, not necessarily at a technical layer. And then my colleague Louis from the University of Maastricht will take over to say a few details about what is this that lies beneath the surface of the sea. And of course, we will say a few things about what comes next. So, the EU-FarmBook platform is an easily accessible and user-friendly digital platform for the exchange of knowledge among the AKIS actors at the national, functioning at the national and the EU levels. It provides access to content, to material, to information, to knowledge objects, as we call them, that have been created by people working in other projects. And all these knowledge objects are made available by being clustered in specific thematic categories. Anybody can access the platform, get information, retrieve knowledge objects. There is a variety in terms of the modalities in which knowledge objects are available. There are documents available, videos, podcasts, infographics, and a specific feature of our platform is that after having accessed a specific knowledge object, you also get some suggestions about what other knowledge objects could be of interest to you. Of course, this is a feature that we are currently working on, and we will work more in the future to make it work in an even better way. And of course, there is always the option to do a search by using the search bar available even on the landing page of our platform. Do a search by using either a single or a multi-word query, and receive results which can be displayed in various ways. And of course, use some filtering options in order to, let's say, tailor the results that are delivered in the specific needs of the person who needs the information. There is the option to comment on the content that is available in the platform, and this is a very nice and important, I would say, feature, because by providing such capabilities through our platform, it is up to the user to decide what is useful to him or her, and probably provide some suggestions to other users about what they could probably find interesting. And as regards what is currently in our database, this is a graph that shows the year of creation of the knowledge objects that have been ingested into our platform till the end of the previous project, the Eureka project. At this moment, there are approximately 900 knowledge objects in our platform. Most of them were created in 2018, which means that we need to continue ingesting knowledge objects into our platform as soon as possible, because someone might say that the knowledge that is available in knowledge objects which were produced back in 2018 may be obsolete at the moment, and this is a huge issue, how to keep pace and be on the same page with the current developments in the field. As regards the purpose for which the knowledge objects in our platform have been developed, there was a mention about the educational aspect of our platform. The main purpose, the main intent for which the knowledge object in our platform have been used is dissemination. In any case, we are dealing with material that is produced by the various projects for dissemination purposes, but you can see that the second more popular, if I could say so, purpose for which knowledge objects have been produced is that of education and training. And as regards the languages in which the content of knowledge objects into the platform is available, English is, I guess that this is something that was expected, the most prevalent language.
Good morning, everybody. My name is Lewis Powell. I'm a software engineer at the University of Maastricht. I hope some of you haven't seen some of these slides before. I hope my voice is somewhat more pleasant than some of the sounds that were coming out of the speaker when you entered the room this morning. And I'll take you through what's going on in the background here. So I think for most of us with the FarmBook, it's kind of clear what will be in the front end in terms of websites that you're used to using, but a lot goes on behind the scenes. So we have three really primary types of objects that sit in the background of the FarmBook. We have the knowledge objects themselves, these practice-oriented materials generated by EU-funded and national research programs, and metadata. So this is how we describe a knowledge object. We have some more information about this on the following slides. One really key thing I think we don't discuss a lot is all the user content that we will get from the platform. So once a knowledge object is uploaded, we will be able to look at the type of search terms that users are putting into the platform in order to get connected with knowledge objects. We see how long they sit on the site, how many different searches they need to go through in order to get to a knowledge object, and then whether or not they spend real time looking at that object, if they share it, and obviously we get their comments and flags that they post. So although we will obviously be generating this information inside the FarmBook, I think it's something to consider for projects that perhaps we share that information back with you so you can see who's using your knowledge object, what they're doing with it, and maybe use that to enhance some of the metadata you provide so that you might reach more people or reach more people who are interested in your type of information. So specifically about knowledge objects, so these are practice-oriented materials resulting from research in which the objectives are drawn from professional practice and in which the knowledge created in the research contributes directly to this practice. And as was already mentioned, everything here is grounded in science. So these knowledge objects can be anything. So they can be text documents, videos, presentations and slideshows, and perhaps a knowledge object is made up of multiple types of data. We could have podcasts, for example, software applications. I don't think we have any software applications currently sitting in the database, but certainly that might be something, some open source solutions that can be shared from projects. And of course, data sets and images. So any type of these objects can be uploaded to the platform. And then when that's uploaded, we then provide metadata for each of these knowledge objects. So metadata is normally described as just data about data, so something that describes and gives information about other information. And in this case, this is our knowledge objects. So there are kind of four primary places that we collect metadata. First of all, we get it directly from the individuals or projects providing this when they upload a knowledge object to the platform. So this is normally a bit more of a manual process, and this might just be something like, for example, the name of the project, the subject of the knowledge object, the title of the knowledge object. So these we rely on the providers of the information to be able to give us at the point at which they upload it to the platform. The next thing that we're working on at the moment are these kind of AI or kind of machine learning things that sit in the background of the system. So we have some very talented colleagues that are working on this in our work package 1 and work package 2 within the FarmBook. So these are metadata properties that will be generated automatically using techniques such as deep learning or natural language processing, which you may have heard of. So as an example here, something like a podcast or a video may be uploaded to the platform, and that in itself is just, say, a video or an audio file. It doesn't have a lot of textual information around it. It doesn't have things that would help a user search for that knowledge object. So we'll be able to use some of these techniques in order to, say, turn an audio file into a textual representation of what's in that audio file, and then match some of that text with, say, open source ontologies that might have key information about farming and forestry. And then if a user comes to the website and types in one of those key terms, even though technically no one wrote that information down somewhere, they get connected with that knowledge object, and then they can go from there. We also obviously have the big challenge of language translation, and this is something that won't be solved overnight. We will need to look at all the different software and tools that are available, but our goal with the platform is that eventually everything that we have in terms of metadata and information in the site will be available in all of the applicable EU languages. So that really means that you can produce a knowledge object in one location and in one language, but then someone else who lives in an area where they can use that type of information will be able to consume it even if they don't speak that same language. And then finally, like we mentioned, the EU-FarmBook itself will continue to generate metadata in the background based on content and interactions. So all of the comments that are left against the knowledge object, all of the interactions that users have with knowledge objects will be data that we can share and use to enhance our system. So now we move on to the question of interoperability, which is really the key of linking all of these different platforms together between the projects and thematic networks and the EU-FarmBook itself. Interoperability is the I in the FAIR data principles that my colleague Christopher will discuss in a second. So interoperability is the ability of different systems and applications across multiple organizations and entities to connect, communicate, and share data and information in a coordinated way without effort from an end user. So really here we're looking at ways in which we can automate the connection between these different platforms and not rely on a lot of manual work and input. So there's a few kind of key parts behind interoperability. Standards are really just the type of structure of the data that the information is sitting in. So there are things like JSON and XML or CSVs that people will be quite familiar with. So it's really important that by using these open source standards, we can encourage these links between platforms. So if you use proprietary software, it may not be using an open source standard, and then there'll be an extra level of, say, manual work that will be needed to convert that into an open source standard in order to make it interoperable. Metadata itself, like we just discussed, is a real key part of interoperability, so providing data about the specific thing, in this case the knowledge object, and giving it rich and descriptive metadata. And then semantics, so particularly in the domain of forestry and agriculture, there are these open source ontologies. We also have the DG Agri list of key topics. So rather than just providing a set of terms that are maybe only specific to the project, by providing the actual terminology used by these ontologies, and ideally the actual link, so the unique references to these ontologies, this will help make data interoperable. And then finally, and kind of unavoidably as well, is of course the element of governance, and in particular GDPR, but this really lets the users of data as well know that they can trust the data and that it's of high quality. So why is interoperability important? So there's a few key points here. So we want to enable data sharing, making sure that you're connecting the right users with the right type of information. So we don't want people to come to the EU-FarmBook, type in a search term and be linked to a knowledge object that's not applicable for them. So it's important we use the data to link the people with the right information. And of course, from a multi-language perspective, there are some things we can really take advantage of here. So for example, with AgriVoc, if you use key terms that are linked to the AgriVoc ontology, a lot of the language translations have already been done in the background. So we straight away could take one bit of information in one language and automatically convert it without any effort on our side, which is quite a big benefit of this type of thing. In terms of what it supports, collaboration and upscaling, so our ability to link these different platforms together and remove this kind of manual overhead. It really helps with decision making. If the data is accurate and understandable, we know we're not making decisions on incomplete data. Certainly by using the links to the data to an ontology rather than just a word itself, that helps with findability and in particular say with things like Google and bringing people who are searching on Google over to our platform. And by making people be able to understand the context and content. So sometimes you might come across some information and without really understanding the context, it's very hard to know how to consume it. So this is a real big part of interoperability. And then finally, this will help reduce costs and repetitive and manual work. So like we've already said, a lot of work is going on into producing this platform within the EU-FarmBook. And a lot of the other projects may be able to benefit from the work we're doing there rather than having to start from scratch and develop a platform completely in isolation. And certainly in terms of making sure data is accurate and complete, it reduces risks of misunderstanding information and making incorrect decisions on the back of that. So a few things that we're doing on the FarmBook to support interoperability. So for generic properties, we're using open source vocabularies like schema.org or Dublin Core. So this is that. So for example, when someone is annotating a knowledge object, a word like the name can mean many things. It could be the name of the project, the name of the author, the actual title, say, of the knowledge object itself. So we will tag all of the information in our metadata, so it's really clear that when you're looking at a particular element of data linked to a knowledge object, you know exactly what that really means. For the domain-specific properties, we will make links to the domain ontologies like DG Agri and EIP Agri. And then for data types, we will just enforce data type standards. So things like dates that can sometimes be in different formats depending on regions, we will clean that up, and same thing with the numerical formats, just to make sure we don't collect information that then needs to be processed afterwards. And it's worth saying that this is a continual improvement cycle. Interoperability is a goal that we will be constantly trying to get towards. So this is something that we will constantly keep in the back of our mind as we improve our knowledge reservoir. So then last few things, so just to talk about what comes next. So we've inherited from the Euracnos and Eureka project the data model and system architecture and metadata and already the knowledge objects that have been uploaded. And we have the personas and user journeys. So we have our pilot platform that's already available, and now we are working through all of the lessons learned from the previous projects. We produced a products requirements document at the end of last month, and we work on these continuous integration and continuous development cycles. And then our goal for this year is to release the first version of our EU-FarmBook platform under this new project. And then for there, we will go back into cycles of looking at the feedback we get and enhancing it and producing new features. So this is really what our our cycle looks like. So we start off by going through requirements negotiation and gathering. We do a technical analysis of the vision of the platform release we're heading for. We validate that with the partners inside our work packages in the EU-FarmBook. We then release that particular version and launch it. And then we do end user testing and feedback. And then we go back into these cycles. So of course, anything that's a big issue, any kind of bugs and issues, they will get fixed straight away. But then we effectively release a new version of a platform and go back into a cycle of deciding what's important for the next version. And then we will, this is a 7-year project. There's a lot of different improvements that will be made in the software and data market. So we get the opportunity to integrate those into our platform, and what we end up with by the end of this year may be very different to the year after, and so on. So I hand over now to Christopher, and he will give a walkthrough of the fair data principles. Thank you, everyone.
All right. For some reason, some mad person asked me to talk about fair data principles and metadata, so I'm going to bore you a bit about that. So I'm going to talk about metadata and ontologies and the fair data principles. The time has come, the walrus said, to talk of many things, of shoes and ships and sealing wax, of cabbages and kings, and why the sea is boiling hot, and whether pigs have wings. This comes from Lewis Carroll's Alice in Wonderland. So this raises the question whether the eventual system we will build will actually be able to answer whether pigs have wings. It certainly will talk about cabbages and may talk about other things. So there are lots of strange terms and concepts for most people in this project, because depending on what community you come from, we have to deal with lots of technological ideas that I'm not familiar with. So I'm going to talk here about why we're interested in the fair data principles in the context of the EU-FarmBook. What is this? How do we do it? Why do we do it? But first I'm going to give a little history lesson. And this is sort of a little bit a combination of politics and technology. If we go back all the way to the beginning of the World Wide Web, not the internet, but the World Wide Web, in 1992, Tim Berners-Lee invents the World Wide Web, and this was designed as a web of documents. Documents are very much what we're talking about here. Eventually, Tim Berners-Lee realized that a web of documents was insufficient, and what was needed was a web of data, particularly from the perspective of doing things like artificial intelligence and so on. And from this realization arose a series of technologies that we generally call the semantic web, to gradually turn a web of documents into a web of data. So from this, we've come up with all these standards that you might have encountered, things like RDF, RDFS, OWL, Sparkle. These are all bits and pieces that we are using in the kind of systems that we're building, and are very important for a lot of work in artificial intelligence, much supported by the W3C, which is the institution that supports this. And then in the 2000s, Tim Berners-Lee, still the key figure here, was very frustrated because there was no data out there. There was nothing out there. There was no web of data was being created. So in the classics, this way that computer scientists sort of get things done, you offer a mug to people as a prize, and then everybody spends all night desperately coding or doing something just to win the mug. Computer scientists are crazy, I agree. Tim Berners-Lee came up with the idea of linked data. So you'd get 1 star if you put something online in any format. Remember, this was a time when people were talking about open data. On the one hand, you had the technological people saying we want data to be open, and then you had the political people saying we want transparency, we want to see what governments are doing, we want to know what they're spending money on, and so on and so forth. So you have this movement a lot in the UK, a lot in the Netherlands, a bit less in France, where there's big pressure to put government data out there and make it connected and that sort of thing. This was part of this time. You got 2 stars for making it readable in machine-readable format, something like Excel. And you got 3 stars for using a non-proprietary format like CSV. And if you really wanted to go overboard, you get 4 stars for putting it online in a non-proprietary format and using an open standards to identify stuff, to actually be able to point to it, to give it a URI and say, look, we can find it again by following this particular link. And finally, 5 stars to put things online in a non-proprietary format, use open standards, and link to other data sets. Now, how do you do that? Remember, the average company has 300 databases. If you go to a bank in most countries in the world and say, I need to change my address, some poor little schmuck has to sit there and put that in 5, 10, 20 times into different databases, because nothing is properly linked up, right? So how do you do this? Well, you start talking about other technologies, which we will come to. But the result was that people did this. They did this slowly in the last 25 years, let's say, since the mid-2000s, by connecting up databases, online databases, expressed in these technologies as RDF, and connecting more and more. And the central character somewhere here in the middle is something called DBpedia, which was a database extracted from Wikipedia. And the reason why there is so many red dots is that the people who had money were the life scientists, the medical researchers, the researchers in areas to do with medicine. And unfortunately, agriculture is largely absent there. Not completely, but largely absent. One of the jobs we have in the EU-FarmBook, in a certain sense, is to make sure that we have a nice, large agricultural blob there in this network of interconnected data. So the open science movement, and we are definitely part of the open science movement from a political perspective, there were 2 contrary movements. Here I'm talking late 2000s, early 2010s. There was a panic about open data, right? Problem especially in health, but more generally towards respecting things like privacy, ownership, things like that. So commercial companies didn't like the term open data. Health people were saying, well, if it's open, what are we going to do about patient security and that sort of thing. And generally, as you will have seen with the development of GDPR later on in more recent years, there was a greater awareness of the importance of privacy. On the other hand, you have a country movement, a frustration with research being paid for, but not open, accessible, and frustration from scientists. That work's been done, but where do I find it? I know somebody's got that database somewhere. How do I reuse it? And a frustration from funding agencies. If we bloody well paid for that already once, twice, 3 times, why is it happening yet again? And that's really, as you can see in the previous talk from the European Commission, There is a strong motivation there to make the research available, to make the outputs of these projects available, and to make them available in the long term, so that they don't end up in somebody's drawer, or these days a USB stick that one's lost at the back of the drawer. So there's also, this frustration about research that gets lost, that gets inaccessible. There's a loss of context. When was it done? Under what conditions? What was the framework that research was done? How can I compare it to my research now? How can I compare the results of what was done 5, 10 years ago to what is being done now? All that created a need for, in our area, EU-FarmBook. The result was the European Open Science Code from the European Commission, and from the life science community, they sort of scratched their head and said, okay, linked data is a bit too nice and fuzzy and not really clear. Let's come up with some better principles, and that was the FAIR data principles. It's a very important paper, but the FAIR data principles are a set of guiding principles for how we should produce data and knowledge objects. The main element of this is that it should be findable, it should be accessible, it should be interoperable, and it should be reusable. And this is broken down in each case to very specific meaning for these terms. And it's all about what Lewis was talking about, the metadata that we attach to a knowledge object. Metadata to assign unique identifiers, unique metadata to express who has access under what conditions, metadata to make it interoperable, that is that you can connect it up or reuse it in an easy way, and metadata to make it reusable in terms of the governance. Who has access under what condition? What are the rules of reuse? Can I use it for a commercial project? Can I use it for education? Can I use it for all that? And you will notice in a lot of EU calls now, the European Commission calls, that using the following the FAIR data principles is a fundamental component. So there are consequences. There are lots of here rules, no, not rules, let's say advice that you should follow if you try and follow these principles. Things like let's say, selecting a repository at an early stage and check out its format and metadata. Make sure the repository is permanent, is going to have a long life to it. Make sure that there is, guarantee the longevity of the data. Make sure that you're using commonly used data formats, whether it is for the actual knowledge object itself or for the metadata about that. So I'm not going to go into all the details here, but there are consequences to trying to follow these principles. One of the consequences that follows more or less is that you have to use some form of semantic technologies. You have to make sure that you have metadata to make the knowledge object findable. So that means you need to use ontologies, taxonomies, vocabularies that are widely used. You need to have unique identifiers. You need to make the metadata accessible. You need to use commonly used protocols. And you need to have access controlled under certain circumstances, particularly if the data is sensitive. You need metadata for the knowledge objects to be interoperable, so again, you need to use agreed ontologies. And the ontologies must follow FAIR principles as well. And when it comes to the reusable, you need to think about licenses. We take a default perspective of using a Creative Commons license within the EU-FarmBook, but we do give people the option to give more specific, more fine-grained licenses, or completely other licenses if you think it necessary. What do we mean by metadata? This is an example of metadata. Here's from Zenodo, a repository that's supported by CERN and the European Commission. Here is an example from Wikidata. This is metadata. This is what it looks like. It's nasty. It's not for people to look at. It's for machines to process. Ontologies. What is an ontology? Well, if you really want to learn more, you come to our session this afternoon. But it's just a machine-readable formal way of describing part of the world. There are lots of ontologies, and they're central to creating this link between different data sets. They typically use RDF, RDFS-OWL formalisms to be machine-readable. In food and agriculture, there are lots and lots of ontologies. I remember being in a meeting a few years ago with the telecommunication community saying, we will build the ontology for agriculture. It doesn't exist. And I put up my hand and said, you know, there's this website where they list over 300 vocabularies for the agricultural sector. It's interesting what people don't know about. Okay, so some of the leading ontologies are AgriVoc, which we're definitely using, Foodon, Agro, Envo, and so on. One that I haven't mentioned, oh, there's an interesting one from Finland. It's only the Finnish who've produced forestry ontologies. I wonder why, because they have a lot of trees, but still. Unique identifiers, and I will shortly finish. It's very important. How are we going to identify each knowledge object in a unique way that we can find it and point to it and refer to it? Now, it's easy for published academic papers. That has been now established in the last few years. Every paper has a digital object identifier, a DOI. But there are lots of outputs of EU projects that don't have DOIs, that don't have anything. They're just deliverables handed over to the European Commission. Then we have things like practice abstracts. How are we going to give unique identifiers to practice abstracts? People. Some people have ORCID or Google Scholar identifiers, but there's lots of people who contribute to projects in various ways who have never bothered, have never thought about this. And projects, we could use Cordis identifiers there, but perhaps there might be a better way. I mean, this is an area where the EU-FarmBook really we need to sort of actually work and make clear what our rules are and what principles we will follow, because this is an important area to make the whole thing a success. So why do we do this? This is my last slide. It enables better search interfaces, for example, faceted search. Faceted search is what you get when you go to a website selling clothes and you can say, I just want men's shirts which are pink or something like that. Same thing for the for the EU-FarmBook, we should be able to say, I'm only interested in pink pigs or something like that. It enables the extraction of structured knowledge into a knowledge graph. This works well with providing recommendations. It's going to be very important for our future chatbot. It enables project impact over time to be more visible, and it enables certain kinds of open science to be undertaken. Also, it enables the creation of distributed networks of knowledge object databases around Europe. So all this infrastructure that we're building is really not just for us to hold on to all the data, but also to make it possible to have a network of repositories of databases across Europe, all integrated and talking to each other. And all that is important. If we agree the principles, the technological underpinnings, then every repository will be able to talk to each other properly. I hope that enlightened a little bit further. If you have any questions.